Hi, I'm Vaibhav Sharma. For my final project, I have implemented convolutional neural network. The implementation is without the use of any of the neural network libraries such as Theano, Keras, Nolan. I've used just NumPy to store the complete data, complete training data set. As far as my focus for the project is more of implementation, like make the network work rather than focusing on the efficiency. Some the data set that I used to for my project was basic MNIST data set and some modification of MNIST data, such as that one of the data set include background images. There was some random background images as well, and one of the data set was the MNIST numbers were rotated. The code is written in Python 2.7 and uses NumPy and Matplotlib. So, though the application supports multi-convolutional layers, but for the testing purpose, I just use single convolutional layer. The local receptive field I used was 5 cross 5, 5 by 5. The padding layer was two layers of zero padding. The stride I used is one. Pulling max pulling dimension is 2 by 2. The feature maps is now 32, and the activation function for the convolutional layer is ReLU. For the fully connected layer, I just had one hidden layer that is of size 1024. The activation function is softmax and loss function is log. The value of eta and lambda are chosen randomly. There is no specific reason about for choosing these values. The output for the MNIST basic data set, as you can clearly see that the cost function is going down in the initial part. This is because of the regularization I applied in my code. As when I initially ran the code for the complete data set, it took more than 4 hours to run just one epoch. So fine, that's the reason I brought it down to training input size of 20. The number of epochs I reduced to 30, and the validation data size was 10, and test data size of 10. That's the reason I'm not getting better accuracies, because the learning might have stopped. Similarly, for I got the similar result for the rest of for the other data set as well. So as I talking about the background image, you can see that the numbers have some background images. I got the same results here. If I go back for the random background images, that's a similar pattern. As you can see, the efficiency is somewhere around 0.25, but you can see the cost reducing initially. That's the same case for rotated MNIST digits. So for the further enhancements, I would like to improve the efficiency so that I can run this code on the complete data set. So I found like I can improve the efficiency by implementing IM2 call approach, which I found over the internet, but currently it's not implemented. I could also clean some memory by using the del function, like some of the data structure that I've used, but I'm still keeping it. That's the cleanup I can do to improve the efficiency. As far as from the overall architecture point of view, I saw that there's a lot of scope for concurrent processing. So a lot of calculation can be done at the same time concurrently. Also, I have not implemented early stopping. If I implement that could be a major improvement in the efficiency. Apart from that, I would also like to explore new other neural network libraries such as Theano, Keras, to more understand how they have implemented the backpropagation and backpropagation. So, thank you. That's all from my side. Apart from that, I've also included the learning sources. These are the learning sources I have used. This is the my source code is at the following in this following link, and these are the links for where I got the data set. Thank you.